Okay, so today we're going to be talking about trig identity. So a trig identity is when we're trying to show that two equations or two formulas or two expressions are similar or equal to each other. Similar doesn't make sense, but that they are going to be related. And you're going to use this, we're going to kind of develop this concept. You'll use this over the next couple of years. And so it's kind of the building blocks of trigonometry for your future self. Okay, and so I think the first thing that I want to talk about would be, if when we're doing a unit circle, you know that when the hypotenuse is 1, your angle is theta, the x coordinate is going to be the adjacent leg and the y coordinate is going to be the vertical leg. And so you know that we've talked about, sine of theta is going to be the y value or the y value over 1. We know that cosine of this value is going to be x. Tangent would be y over x. And then we also know the reciprocal functions. We're like, okay, well, cosecant of theta is going to be the reciprocal of sine, or you can do 1 over y, or you can just take the fraction that is the y coordinate of the unit circle and flip it over. And same with secant. You can take the x coordinate and flip it over. And then for cotangent, you can take, instead of y over x, you can do x over y. And so those are true, and we will use those for the unit circle for a very long time. And then we'll also use SOHCAHTOA in general as well. But I think the next step is to say, okay, of these trig identities, which ones can we kind of feel and see what is going on here? Well, tangent, if tangent is indeed y over x, okay, think about this, okay? But if sine is y and cosine is x, think about this. Tangent could be written as y over x, or you could write it as the sine over the cosine, which is kind of interesting, okay? And then cotangent could be written as x over y, which is another way to say cosine over sine. So these are things that you can say, well, if I say tangent, I know it's y over x, but I also can say is going to be sine over cosine. And so that's kind of an interesting situation to be able to look at that. And this is pretty deep in terms of what's going on, but I'm trying to say, can I have it slightly find a home in your head? Okay. And, moving further, sometimes people will talk about tangent being the slope because the rise over the run, so y over x. So those are a couple of things that you will see as you move forward in math. Another thing would be the reciprocal identities. Not only is cosecant the reciprocal of the y coordinate, but also if you know sine, say sine that is a half, the cosecant is going to be 2 over 1. And then furthermore, if you know cosecant is 2 over 1, then the sine would be 1/2. So you can take the answer for sine or the answer for cosecant and move between one and the other by doing the reciprocal, moving back and forth. So that's what they're talking about over here on the left. And I think that's good for us to look at to say, if I know sine, I can flip over sine to get cosecant, but if I know cosecant, I can flip it over to get back to sine. And so these two are related, not just because they're, the hypotenuse over the opposite or the opposite over hypotenuse, but also they're going to be reciprocals of each other. If you know one, you can take the reciprocal and get to the other one as well. Okay, moving back and forth. And then same for cosine and secant. Not only is cosine going to be the adjacent leg over the hypotenuse, and if you know the cosine, you can flip it over to get to secant. But also, if you know secant, you can flip it over to get back to cosine. So that's kind of a true statement. And then it makes sense that if you know tangent, like say tangent's 3/4, well, then the cotangent would be 4/3. And then vice versa. Okay, those move back and forth as well. So there are multiple ways to express tangent, okay? And I'm giving you some options. Okay, so not only is there a fraction for tangent, sine over cosine, it's y over x, but also it's the reciprocal of cotangent. So you'll have to, as we're doing these problems, you'll be looking to say, what can I do to represent tangent a slightly different way? Now, the most common things that you'll see moving forward would be the Pythagorean identities. Okay, so we're going to be talking about this as well. Okay, and you'll see this quite a bit in your future self. Okay, if you know the Pythagorean theorem is a squared plus b squared equals c squared, and if you know sine and cosine are both x and y, so this is cosine and this is sine, of theta. Okay. You know, instead of writing x squared plus y squared equals 1, you could instead write sine squared plus cosine squared equals 1. Okay, 1 squared, which is 1. And so this is probably the most critical trigonometric identity right here, the Pythagorean identity, which is sine squared of theta plus cosine squared of theta equals 1. And from her, you launched two sister identities as well. And if you know me well, which you do, you know that it's hard for me to memorize lots of different formulas. And so in general, they'll hand you lots of these, but the older you get, the less they will give to you. And so if you are expected to be able to come up with the Pythagorean identities without a crutch, without being given them, here's a way for you to come up with them from your own brain. Okay. And so if you are doing, taking, oh, I don't know why this isn't coming with me. All right, well, whatever. If you are doing sine squared plus cosine squared equals 1, and you want to come up with the other two below there, this is how you do it. Okay, so I wrote sine squared plus cosine squared equals 1 3 times on your paper because that's kind of the parent. Okay, and what we can do is, yes, this is the most important one. That's the one that is going to be used most frequently. And so if you're doing some problems and you notice it has something squared, sine squared, or cosine squared, or tangent squared, or cotangent squared, probably you're going to use one of these three. And so to derive or come up with these other ones without having to memorize them, here's what you do. Well, you say these other ones have other words in them, and they also have a 1. Well, how can I make this first term to be 1? Well, I can divide each term by that first value. I can divide each term by sine squared of theta. Now, here's the deal. If you don't put the squared after the word sine, it will say sine of theta squared, and then you would square theta and then take the sine of it. That's not what we're talking about. We want to take the sine of theta and square that answer. And so that's why they put the square on the sine, the word sine. Okay, so, and you'll notice that's for inverse sine as well. So if you divide each of these terms by sine squared, and again, in an equation, you're allowed to divide all the terms by whatever you would choose to. You can't divide by 0. So we're saying excluding the value in sine and 0, but we're going to say divide each one by sine squared. And then if you reduce this first one, you get 1. And then you have to say, well, if I have cosine squared over sine squared, well, cosine over sine is cotangent, correct? Well, cosine squared over sine squared would be cotangent squared of theta. And then 1 over sine squared. Well, 1 over sine is cosecant, right? So that would be cosecant squared. And that is this formula here on the bottom. Okay, so you can memorize that. You can rely upon being given that, or when you get to a point where you're like, hey, they're not going to give us these trigonometric identities, you will have to make sure you can either memorize all 3 of these Pythagorean identities or realize that they all come from sine squared plus cosine squared equals 1, and you just divide by either sine squared or cosine squared. So the last formula you're going to do is you're going to divide. Okay, so if I divide everybody by cosine squared of theta, it's a little hard to fit here, and cosine squared of theta. Okay, so the first one, sine squared over cosine, well, sine over cosine is tangent, so sine squared over cosine squared would be tangent squared. And then, oopsie, plus. Cosine over cosine squared is just 1, equals 1 over cosine is secant, well, so 1 over cosine squared would be secant squared. And if you can see that, that is our third, the other trigonometric or Pythagorean identity. And so the 3 things we're going to be doing today are pretty similar. The first thing is, can you simplify? You're like, well, that's pretty vague. Okay, well, notice the goal is to write it with as few trigonometric words as possible. Okay, so let's scooch this up. I'm going to move away these words. Here we go. Okay, so tangent and cosecant. The methods you use are generally, if you see 1 minus cosine squared, you can probably substitute a Pythagorean identity into there. If you see something that can be factored or gotten a common denominator and combined like terms, or just writing everything in sine and cosine. Those are all methods that you would use. And so we're going to practice with some of these. And the truth is that this year you're going to, become good at a couple of those things and notice, hey, there's a couple of things that you can do. But over time and over the next couple of years, depending how many more math classes you take, you will become increasingly good at these identities and then also the ones that are after this as well. And so this is kind of an intro to, can you use words and reduce them? So let's practice a little bit. This first one, we are going to move everything to sine and cosine. So if you go up to the top, there's tangent. There are a couple ways to write tangent. One is going to be the reciprocal of cotangent, so 1 over cotangent. Another one is going to be sine over cosine. Okay, and so I don't see any squares in this, so we're not going to use a Pythagorean identity. But tangent is going to be sine of theta over cosine of theta. And sometimes if you have options, you got to be like, well, let's try one and see what happens. Now, cosecant is a reciprocal of secant, or of sine. And so that's what we're going to do. We're going to say this is 1 over sine theta. Okay, and so notice when you're multiplying and you have common factors on top and bottom, you can reduce that. So you're going to get 1 over cosine. And again, we're trying to reduce it as small as possible. So 1 over cosine is good, but we're going to go to what could we write it as? Well, secant of theta. We want to go as small as we can. So that would be our final answer. Okay. So secant of theta would be our answer. That's the smallest way. They're both equal. We're trying to get it without fractions if possible, just one word, as small as possible. Okay, the second one, if you notice, it has 1 minus cosine squared. So if you see a squared on it, it's possible and pretty likely, at least at this stage of the game, you're going to use one of the 3 Pythagorean identities. And so this has cosine in it, and the one that has cosine in it is the one that says sine squared plus cosine squared equals 1. Okay, and you're like, I don't see sine in the picture, so let's see if we can solve it for sine and see what happens to that. Okay, so if you minus cosine squared, you would get sine squared of theta equals 1 minus cosine squared. And so sometimes you got to try a couple things. You're like, what do I do? Well, I just see cosine squared in it. So if I solve it for the one that's not mentioned, well, then maybe that will help us to do this. So 1 minus cosine squared can be substituted to be sine squared. So in place of 1 minus cosine squared, we're going to write sine squared. And this is a process that we're going to work on getting better at. It is not exactly fluent and like something that's super intuitive, but it's something that we can grow at as we practice, as we work together. Okay. Cosecant. Well, it doesn't say squared, so we're not going to use a Pythagorean identity. We will use cosecant is going to be 1 over sine. Okay, so this is the question. If you've got sine squared over sine, one of the signs will cancel out, correct? And then you're left with just a sign on the top. Sine of theta is going to be our final answer. I don't know what word that looks like, but there you go. Sine of theta is going to be our answer. So we're trying to simplify. So we started with 3 different things and we brought it down to 1 word. Okay, so that's awesome. Now look at C. Now there are those who are like, I'm going to subtract. Have you thought about PEMDAS? We have secant, and then we're subtracting the product of secant times sine squared. You have to multiply secant times sine squared, and you can't just say I'm going to minus first and then times. No, PEMDAS says you can't do that. So you can't just get 0 times sine squared. That's not going to work. So the thing that we will do is factor. Do you see that in our 2 terms, they both have secant? So if we take out a secant of theta, we're going to be left with 1 minus sine squared. Okay, so yes, you can factor. That's really one of the, situations that presents itself in these kind of questions. And so 1 minus sine squared, well, that's a Pythagorean identity. Okay, 1 minus sine squared. Well, if you've got sine squared plus cosine squared equals 1, and I tend to abbreviate like that so that I can show like, hey, what could I do to get 1 minus sine squared? Well, cosine squared is not mentioned. So if you solve it for cosine squared, you could minus sine squared from both sides. You get cosine squared equals 1 minus sine squared. And you can't leave your answer like that. We're just kind of doing a little math to be like, okay, 1 minus sine squared is equal to cosine squared. So instead of 1 minus sine squared, we can write cosine squared of theta. And yes, you should write that when you go to do your math in your problem. Okay, make sure you write theta. You can't just do cos and sec. You do need the theta or an x, depending what letter we're talking about. Okay. And then cosine squared times secant. You're like, well, I bet you I could reduce that. Okay. Cosine squared and then secant. Secant is what? What's 1 over cosine? Okay, so the truth is if you have cosine squared over cosine, well, then one of the cosines will reduce and your answer is cosine of theta. So we're really practicing, can you reduce fractions a little bit? Can you factor? Can you use the Pythagorean identities? Okay, this next one is like, all right, well, there's 4 different items. Okay, sine, secant, cosine, and cosecant. So the question is, what can I do? There's nothing squared, so we're not going to use a Pythagorean identity. However, we could move everything to sine and cosine. Okay, and so secant is the reciprocal of cosine, correct? And then if you've got that times sine of theta, and then you've got cosine of theta over 1 over sine of theta, okay, then you're like, okay, well, sine over cosine is just tangent, and cosine over sine is just cotangent. And that's as close as you can get, okay? So you got 2 terms, and it's better than what you started with, okay? And so I think when we move to the back, you'll notice that it says prove trigonometric identities. And you're like, well, what do you mean prove it? Well, if you remember earlier in the year, you are allowed to, when we're doing trigonometric identities or algebraic identities, you can only mess with one side of the equation and show, hey, it equals the other one. So we're kind of demonstrating that this equation is true. You're not solving for anything. We're not trying to find theta. We're just trying to say, hey, notice this is something that is true. And so you can only touch one side. And normally I would say go with the messier side and try to tidy it up. That's not always the truth, but sometimes that's a really good way to start. And sometimes there's ways to manipulate one or the other. There's 2 ways to get to the answer to show that they are true. And so if you see something a little different, you are super welcome to talk to me, or you're welcome to, explore other options as well. Okay. And so there's not always just one way to do these questions, but you can only do one side or the other. That is one of the rules. And so if we look at this, we're supposed to show that tangent equals secant over cosecant. And so the question is, how would you do that? And so what I'm going to do is I'm going to say, okay, I'm going to try to tidy up the right side. Well, secant is 1 over cosine of theta. I'm not sure why my pen is not writing. And cosecant is 1 over sine of theta. And then if you divide this fraction, it's the top divided by the bottom, and the bottom one gets flipped over, doesn't it? So it's going to end up being times by sine over cosine, or sine theta over 1. All right, so when you do division, your denominator gets flipped over. And so you can say, okay, well, guess what? That's sine over cosine. That is tangent of theta. So tangent of theta equals tangent of theta. So you would draw an arrow to say, hey, notice, look, the right side is tangent. Okay, I showed my steps. And then that is going to prove that tangent equals tangent. So this equals that other value. And so the next one is like, okay, can you show that these are true? Well, this one's not too bad because it is an example of cotangent is cosine over sine. And you know that for cotangent, you could do 1 over tangent, but that's not going to help us very much. Okay, so this is cosine over sine. And our sines will cancel out because it's common factors on top and bottom. And so you just get cosine of theta. You say, yeah, look, it does. Okay, so you're showing things that are true, and you could formally prove it, but just make sure you show your steps. You're like, hey, look, I'm going to show that this is equal to cosine. On the third one, that's a little tricky. You're like, I am not sure how I would do this, okay? And I'm going to say we're going to focus on the right-hand side. And then this is going to get a little messy, but it's not too bad, okay? And so if you have cosecant minus sine, cosecant is going to be 1 over sine minus sine of theta, okay? Well, the thing is this, if we want to subtract these, so common in this is factoring. So common also is us saying, hey, can you get a common denominator and subtract things or add 2 fractions together? So that's what we're going to do here is we want to subtract these because there's really no forward way for us to get to the left side of the equation unless we subtract these fractions. So I'm going to times the second fraction by sine of theta over sine of theta. And you're allowed to times any fraction by 1, and sine over sine is 1. And so if you add these fractions together, you're going to get 1 minus sine squared of theta over sine of theta. Okay, and so sine times sine is sine squared, so 1 minus sine squared over sine. And then we're like, okay, now what do I do? Again, look to see where your goal is, because sometimes you're like, I can do things, and that may be simplified, but the goal is to get to match the left side. Okay, 1 minus sine squared is a lot like a trigonometric Pythagorean identity, right? And so we're going to do sine squared plus cosine squared equals 1, and we've got 1 minus sine squared. Well, if I solve it for cosine squared, I'm going to get 1 minus sine squared. Okay, and so in place of 1 minus sine squared, we're going to put cosine squared. So you're going to put cosine squared of theta over sine of theta. You're like, this is not what we have on the left side, okay? So, but it's closer, okay? And so the question is, can I get to cosine times cotangent? And the way we're going to do this is we're going to spread this out, okay? We're going to say cosine squared means cosine times cosine, right? So if I do cosine of theta times cosine of theta, and it's over sine of theta, right? So you can put sine of theta as your first, underneath the first part of it, okay? What do you mean, woman? Well, look, okay? If you do cosine over sine, that is cotangent, isn't it? And that's times cosine. So it's kind of weird to be like, okay, cosine squared over sine doesn't look like what we have over there. But if you write cosine squared as cosine times cosine, all over sine, okay, well, the first fraction times cosine is going to be cotangent times cosine of theta. And that is true. Okay, so you say, okay, great, we did it. And we bring this down. There's not a lot of room here, but it's what we're working with right this second. Okay, let's do 4, 5, and 6. If we've got, let's see if I can get this to go. Sine minus cosine over sine. You're like, okay, well, what one do we want to work with? Okay. I'm going to work with the one on the right and then write it as fractions, get a common denominator, see if I can make it look like the left one. Okay, so that's my overall procedure here. So 1 minus cotangent is going to be 1 minus, that's going to be cosine of theta over sine of theta. And again, how would you make it into a common fraction? Well, we've got to get a common denominator. So I'm going to multiply this first fraction by sine over theta, sine over sine. Sine of theta over sine of theta. So that I can get a common denominator. So I'm going to get sine of theta minus cosine of theta over sine of theta. Wait a minute, that's what we wanted to get anyway, wasn't it? So making them into fractions, getting a common denominator, and then adding or subtracting is really a valid situation. Okay. Now, my students yesterday were like, hey, let's just minus the tangents and then times by sine, okay? And so tangent minus tangent and then times by sine, that's sine squared. Look, we did it. Like, first of all, you have to do PEMDAS, okay? You have to multiply these together, and then you can subtract these two values. The second thing is if you do tangent minus tangent, inappropriately, that's 0, and 0 times sine is not sine. Okay, so sine squared. So you got a couple mistakes. So don't follow these people. Okay, so what I would say is, what can I do to the left side to tidy it up? Well, I can and should factor out tangent squared. And I get 1 minus sine squared. Okay, and so the second question is, what should I do next? Okay, well, if you do sine squared plus cosine squared equals 1, 1 minus sine squared is equal to cosine squared. Okay, sine squared plus cosine squared equals 1. If you solve it for cosine squared, you're going to get cosine squared equals 1 minus sine squared. And so in place of 1 minus sine squared, you're going to put cosine squared. Okay, and you've got it times tangent squared, right? Our goal is to get to sine squared. So probably we should convert tangent squared into sine squared over cosine squared. Okay, we could have done a Pythagorean identity, but again, our goal is to get just sine squared. So sometimes there are options. If tangent is sine over cosine, well, tangent squared would be sine squared over cosine squared. So you kind of have to look and say, okay, where am I headed? You know, I don't want multiple terms. I just want a single sine squared. So changing it into sine over cosine or sine squared over cosine squared is going to help us best. And so we get sine squared equals this side right here. Okay. So we are making progress, and these are skills to say, okay, sometimes it's making fractions and adding or subtracting with a common denominator. Sometimes it's factoring, okay? This one right here, we're like, well, if your goal is to make a fraction, a lot of times what you should do is to make something into fractions and then add or subtract it. Well, here's another option, okay? On the right side, the numerator is 1 minus sine squared. Okay, 1 minus sine squared is cosine squared. We've done that a bunch of times today, cosine squared of theta, and that's over sine cosine. Okay, so you're like, my goal is to get that. Well, let's spread this out, okay? If you, let's see what we can do. Okay, so if you look at this, you're like, oh, I'm a little stumped. Well, you do know that one of the cosines will cancel out. Okay, so you get cosine of theta over sine of theta. And so the question is, if we were going for cotangent, we'd be, slam dunk, but we're not. We're going for cosine and cosecant. And so the thing is, we can sometimes split things apart into their factors. And I'm not saying factoring, but split them into their multiplicative factors to say, yeah, cosine over sine could be written as, and I'm going to kind of work this backwards and say, okay, I could do cosine of theta times 1 over sine of theta. Do you see how I'm splitting that into two factors? Okay, cosine times 1 over 1 times sine, but this is the deal, okay? What is 1 over sine? Well, that's cosecant, okay? So it would be cosine of theta, and that would be cosecant of theta, okay? And so breaking this up into their factors, and when I say factors, I kind of mean factors, but not factoring in the per se of using parentheses, but cosine over sine really is cosine over 1 times 1 over sine, because if you remultiplied it back out, you would get back to your original question. Now, I should rearrange these order to say, hey, look at, now they are equal to the left side of the equation. Okay, so that's kind of a tricky thing to be like, it looks like cotangent, a really big case for cotangent, but splitting it apart into two different factors that will also be called those values is really a clutch move. Okay, that's pretty cool. Okay. All right, so the last one, they're just saying, hey, can you simplify these? Can you write it with one word? Okay. And so not sine and cosine, not secant and cotangent, but just one word. Okay. And so I'm going to stop this. Actually, here we go. So secant and then 1 minus sine squared. Okay. Well, 1 minus sine squared, we've done a couple times. That's cosine squared. And then secant, what are we going to do with that? Well, let's call it 1 over cosine. All right, cosine squared over cosine, that's just cosine of theta. I feel like we've done something like that already today, don't you? Okay. And then this next one, ooh, she's precious. Okay. So again, we want just one word. Well, sine squared plus cosine squared equals 1, right? So in place of sine squared, I can write 1 minus cosine squared. Okay. And that's over 1 minus cosine. Now, got a question. Do you see that the numerator is the difference of two perfect squares? Yes, you can factor that. Okay. How? 1 plus cosine of theta and 1 minus cosine of theta. And so that's going to be over 1 minus cosine. And that factor will cancel out. So your answer is 1 plus cosine of theta. Now, when they say just one word, yeah, there is just one trig function. It's 1 plus cosine of theta. So factoring, yes. And that's kind of a special thing. It does happen sometimes. Okay, the next one has 3 different words in there. So we're going to try to see if we can get it in terms of one word. This might be a little bit tricky. Okay. Okay, so here we go. So to write this in terms of just one word, let's get them all to sines and cosines. Okay. Wait a minute. What is cotangent times tangent? Okay. We could do. Okay. So the rest of these, I would suggest you see, can I, try these? So I would maybe stop the video and be like, let's focus on just doing any one of them and then restart it and say, did I get it right? Did she go the same way? Because sometimes there's multiple ways to go. And then you'll be like, well, that doesn't get me to the answer that I was hoping. And you back up a little bit and be like, okay, because tangent has, a couple ways to write it, 1 over cotangent or sine over cosine or, whatever. Did I rethink this in a weird way? And so I would say, try that. Now, my thing is this, on this number 9, cotangent times tangent, you could write them as cosine is cosine over sine and sine over cosine, but can you think about this to be, well, cotangent is 1 over tangent. And tangent is just tangent. Okay, and so, whether you wrote sine over cosine and cosine over sine, the product of cotangent times tangent is just the number 1. Okay, and so that is something that you could go a couple ways to do that, whether you did cosine over sine and sine over cosine, and then it just makes, both the sines and cosines cancel out, it makes 1. Or if you do the reciprocal functions, your hope is to reduce it. And so then your answer is just going to be sine of theta. So that's kind of a cute question. And so like thinking, you're training your brain to think in different ways. The next one, you're like, okay, there's 3 terms. Okay. And I think the big thing is they're squared. So you're going to use the Pythagorean identities. And so I think the next thing would be to be like, okay, well, sine squared plus cosine squared, they go together, don't they? Now the other ones have their friends. If you look back on the first page, you'll see who are friends in the same equation. But this one, to be honest, you'll see sine squared plus cosine squared is just the number 1, right? So 1 plus cotangent squared. And if you look back at the front, you're like, okay, so what is that? Okay. Well, that's going to be 1 plus cotangent squared is going to equal cosecant squared. And so that's directly from the front page. So that's kind of cute, to be like, that's literally, let's go back here and see which one is it. If this is the first, the second, or the third one of those. 1 plus cotangent squared is cosecant squared. Yeah, that's the third Pythagorean identity. Okay. And then I guess try these, stop the video, see what you can come up with. The way that I'm going to do this next one is tangent plus cotangent. Okay. We want to condense those. And so there's a couple ways to think about it. And one way to do it is to say tangent plus cotangent. We can go to sines and cosines, okay, and add those up together, okay. And so this is going to be sine over cosine, and then plus cosine over sine, okay. And then we can say, all right, well, let's just I guess we could either distribute the sine cosine to them, okay, or we could say, let's add them up and then let's distribute, okay, and so multiply those 2 things together. I think that I am going to distribute, okay, and so if I take both sine and cosine times this first term, the cosines cancel out, I'm left with sine squared. If I take sine and cosine by the second one, the sines cancel out and I'm left with cosine squared. And what's that equal? 1. So that's kind of cute. If you just say, let's convert these so that when I distribute it, maybe we have a hope of things canceling out. Well, we do. Okay, so there's different mathematical principles you can try to be like, do I want to add those 2 fractions? Do I want to distribute? And to see where that leads you. And so you get better by trying things and seeing what happens. Well, I think this next one is going to be pretty nice because if you take cotangent times tangent, you're going to get 1. Why? Well, what is cotangent? It's 1 over tangent. And if you times that by tangent, okay, again, we're distributing, you just get 1. And then if you take cotangent times sine, I'm like, I don't know what that is. Well, let's kind of take cotangent and put it into, a fraction that would represent it. So that'd be cosine over sine. And then your sines would cancel out. And you get 1 plus cosine of theta. So that's kind of cute. We can distribute, but sometimes to cancel things out, you've got to go to sines and cosines so that they will do that, or think about what is true. Okay, the last one. I see a subtraction and a product, and we do have to multiply those before we can subtract. So I guess we're going to multiply those together and see what actually happens. Okay. If I cotangent is going to be cosine over sine. And then it's times cosine. So that's going to be cosine squared. Okay, so cosine squared theta. That's going to be our second term. And the first fraction, or first item, if you do cosecant, that's going to be 1 over sine. So there'd be cosine squared over sine. I forgot the denominator. You got 1 over sine of theta. Look at this. They have a common denominator already. Sometimes you have to get a common denominator. Sometimes you have one. So you've got 1 minus cosine squared of theta over sine. So what do we do? Well, 1 minus cosine squared is sine squared. So sine squared over sine theta. One of the sines canceled out. So your answer is going to be sine of theta. So, I mean, I think the big thing is you've got to realize you have trigonometric identities, and some things have multiple choices of options. So tangent, yes, it could be 1 over cotangent, or it could be sine over cosine. But if you see something squared, you're going to use an identity. And the options you have for reducing would be maybe distributing, maybe combining like terms, maybe factoring, maybe going to sine and cosine. Those are all options to help you try to reduce things. All right. Thank you. Have a good day.